I am Ambika Devi, Assistant Professor, Department of Physics, Government First Grade College, Bidar, from Karnataka State. I am a participant of second online refresher course in physics organized from 21st June 2022 to 4th July 22 by UGC HRDC Gujarat University, Ahmedabad. I am going to deliver my presentation on interference. This is my topic, interference. Okay. So here, all of us we know that when any luminous body, if we glow any bright body, then what happens? Light rays spread in all direction. Light is uniformly distributed in all direction. But when two light waves are superposed with each other, see, for example, if we glow two luminous bodies, then what happens? There is a superposition takes place in between the two waves. This phenomena is known as interference of light. So interference of light is defined as when two light waves of same frequency of equal or nearly equal amplitudes traveling in the same direction overlap with each other, then what happens? There will be a redistribution of light intensity in the region of overlapping. This phenomena is known as interference. Here what happens? Here we are using two waves which are emitted by the same source. Two waves which are emitted by the same source. That's why these two waves are having same frequency, equal amplitude, and moving with a constant phase difference. Then what happens? These two waves overlap with each other or superposed with each other. Then what happens? There is a modification in the distribution of energy. Already I told you, no, if we use single source means single waves. If we use a single source, then here light rays are uniformly distributed in all direction. Okay, uniform distribution of light takes place. But here in this case we are using two light waves, means waves of same source, two waves of same source which are having same frequency, equal or nearly equal amplitudes, and moving with the same phase difference. Then what happens? Here in this case light is not uniformly distributed, but here light is there is a modification in the redistribution of energy. This phenomena is known as interference. This is the example for interference phenomena. Here white light is get superimposed. So here all 7 colors are formed on this CD. This is the example. So this is also a definition. The modification in the intensity of light in the region of overlapping of two or more beams of light. This is in accordance with the law of conservation of energy. There is no loss of energy due to interference. What is the law of conservation of energy? Energy neither be created nor be destroyed. Simply energy is converted from one form to another form. Here also energy redistribution takes place. In this process no energy losses takes place. So main condition to occur the interference of light. What is the main condition? Main condition is here I already explained, no, in interference phenomena we are using two sources or two waves of same source. Those two sources are named as coherent sources. What is the meaning of coherent sources? Coherent sources means any two sources continuously emitting waves having zero or constant phase difference are called coherent sources. Means coherent sources means two sources which are having same frequency, amplitude, same amplitude or nearly equal amplitude, and moving with the constant phase difference. Example, in Young's double slit experiment, the two slits behaves like a coherent sources. Means in the Young's double slit experiment, one source is used and that source emits the light rays in all direction, and all those rays are made to pass through two slits, two thin narrow gap. So whatever be the amount of light which emerges out from the two slits, that is nothing but coherent sources. In Young's double slit experiment, two slits behaves like a coherent sources. And these are the main conditions for interference of light. What are those conditions? We will discuss one by one. First one is the source of the waves must be coherent, which means they emit identical waves. Already we have discussed in the previous slide coherent sources. Coherent sources means the sources which emit, two sources which emit light waves of same frequency, same or nearly equal amplitude, and moving with the constant phase difference. Such type of sources are named as coherent sources. So to perform this phenomena, interference phenomena, two sources must be coherent. And with a constant phase difference, with a constant phase difference means here two waves should move with a constant phase difference. Means the angle between the two waves must be same. And third one is the wave should be monochromatic. Waves should be monochromatic means they should be a single wavelength. Of example, sodium source. Sodium source has one wavelength, 5893 angstrom unit, that is the yellow color. So here the waves should be monochromatic. If we use white light, then also we get the interference phenomena. But if we use monochromatic source, then what happens? We get interference fringes, uh, white and dark, bright and dark fringes. We get interference phenomena which consist alternative bright and dark fringes. Instead of monochromatic source, if we use white light, then we get seven colors, that CD. Already we have discussed in the first slide. That is the good example for interference phenomena. So instead of monochromatic light, if we use white light, then we get seven colors Vibgayar instead of alternative bright and dark bands. And one more condition is the two amplitudes should be should of the interfering wave should be means here two amplitudes of the two waves which are going to interfere, that amplitude must be equal. That amplitude should be equal or nearly equal. Okay, then the separation between the two sources should be small. Separation between two sources means separation between two coherent sources. In interference phenomena, we first condition is sources should be coherent, means we are using two sources, and the distance between, separation between that sources should be small. And the distance between the source and screen, here in this experiment we are using screen also, because first in this experiment first source is there, next two slits, lastly screen is there. First source emit light rays in all direction, and these two sources emerges out from the two slits. That two slits behaves like a coherent sources. After passing through that slits, these two waves which are having same frequency, nearly same amplitude, and moving with a constant phase difference. So here these two waves get interfere or superpose with each other, and it forms a interference pattern on the screen, which is placed at a large distance from the sources. So last condition is the distance between two sources and screen should be large. These are the condition to get a interference of light. See here, students, interference is mainly classified into two types on the basis of producing of an interference phenomena. Here two methods are there. One is by division of wavefront, another one is by division of amplitude. Mm, division of wavefront or division of wavelength. In this concept, what happens, the um, first in any interference phenomena, first we use source, next two slits and a screen. First, source emits light rays in all direction, and these light rays are emerges out from the slit S1 and S2. And these two here, what happens, uh, frequency of the wave, or wavelength of the waves, wavefront of the waves is get divided into two parts. Half of the wavefront is emitted from slit S1, half of the wavefront is emitted from the slit S2. So here single wave is get divided into two wavefronts, and these two wavefronts are emitted from the same source. So these two wavefronts obey the condition for interference. Now these two wavefronts are having same frequency, same amplitude, and moving with a constant phase difference. That's why here superposition is takes place in between the two wavefronts, and it forms a interference pattern on the screen. So here interference pattern consists alternative bright dark bands. By using this concept, these three phenomena are performed. One is Young's double slit experiment, one is Fresnel biprism, and next one is Lloyd's mirror. These three experiments are example for interference which is takes place due to division of wavelength. And next is interference due to division of amplitude. Friends, here what happens when a light ray is made to fall on any surface, for example, thin oil film which is formed on a water surface. If we consider thin film, then what happens when light ray is made to fall on the thin films? What happens on the surface of the thin films? The incident light ray, amplitude of the incident light rays get divided into two parts. Here amplitude is get divided into two parts. Half of the amplitude is get reflected, half of the amplitude is get transmitted. So set of reflected amplitude rays, set of reflected rays on the upper surface, and a set of transmitted light rays on the below surface of thin film. So here these if we consider reflected rays, these reflected rays are emitted from the same source. So here set of reflected light rays are having same frequency, same amplitude, and moving with a constant phase difference. It obeys the interference condition. So here what happens, interference takes place due to division of amplitude. And similarly, in case of in between transmitted light rays also interferences takes place. So examples for this concept is Newton's ring, air wedge, and colors of a thin films. These three experiments are performed by using this concept, that is interference due to division of amplitude. So in this PPT we have discussed about interference, means definition, how interference takes place, what are the conditions to perform the interference phenomena, and methods to get the interference phenomena. Two methods are there, one is due to division of amplitude and the one is due to division of wavefront. So thank you, friends. Actually this PPT is prepared for the refresher course of physics. I, Ambika Devi, thank UGC HRDC Gujarat University Ahmedabad for providing me an opportunity to join second online refresher course in physics. Thank you.